Welcome students, welcome to thermal engineering session. This session we are going to see about a steam and steam boiler unit. Under this we are going to see the difference of pressure for to maintaining the constant flow of air and discharging the gases through the chimney to the atmosphere is known as draft. Okay, so it is a draft is defined as it is a difference of pressure, so that to maintaining the constant flow of air and discharging the gases through the chimney to atmosphere known as draft. So a fuel heated boiler must provide air to oxidize its fuel. Okay, so it needs air to oxidize its fuel. So yearly boilers provided this stream of air or draft through the natural action of convection in a chimney connected to the exhaust of the combustion chamber. Since the heated flue gas is less dense than the ambient air surrounding the boiler, the flue gases rises in the chimney, pulling denser fresh air into the combustion chamber. Okay, so using this natural action of convection, how it is happening means when the heated flue gases it's having a less density than the normal normal surrounding air surrounding the boiler. Okay, when this less dense heated flue gas which rises into the chimney so that it pulls the high denser fresh air into the combustion chamber. So this is the normal process. It means the natural action of convection, how this draft process happens. So most modern boilers depend on mechanical draft rather than natural draft. This is because natural draft is subject to outside air conditions and temperature of flue gases leaving the furnace as well as the chimney height. So these are the factors the natural draft is depending upon. So that nowadays most of the modern boilers they are depending upon the mechanical draft draft instead of natural draft. So all these factors make proper draft hard to attain and therefore make mechanical draft equipment much more reliable and economical. So types of draft can also be divided into induced draft where exhaust gases are pulled out of the boiler, forced draft where fresh air is pushed into the boiler, and balanced draft where both effects are employed. So let's see the classification of draft. So the drafts are classified into natural or chimney draft or artificial draft. So what is this natural draft? So in this natural draft, the pressure difference is created naturally without using any positive displacement device. What about the artificial draft? It is created using some external assistance causing forced displacement of gases. So it can be created either by using mechanical devices or steam. Artificial draft can be further of induced, forced or combination of two types. So artificial draft is further subdivided into steam jet draft and mechanical or fan draft. The steam jet draft is further classified into induced draft and balanced draft, and this mechanical or fan draft is further classified into induced draft, forced draft and balanced draft. Let's see about the natural draft. Natural draft system employs a tall chimney as shown in the figure. So you can see so many power plants, so many industries, they are using this natural draft tall chimneys. The chimney is a vertical tubular masonry structure or reinforced concrete. So it is completely made up of a masonry structure or a reinforced concrete. So it is formed of enclosing a column of flue gas to produce the draft. It removes the gases high enough to prevent air pollution. So the draft is produced by this tall chimney due to the temperature difference of hot gases in the chimney and cold external air outside the chimney. So using this natural draft due to this high structure, so and due to the temperature difference of the hot gases in the chimney and the cold external outside, so that hot gases becomes less dense, it's move up, it may it leaves the cold denser air outside to pull inside. When it when the hot gases becomes less density, it moves up so that it pulls the cold denser air inside the boiler. What are the advantages of natural draft? So it does not require any external power for producing the draft. The capital investment is less. The maintenance cost is low as there is no mechanical part. Chimney keeps the flue gases at a high place in the atmosphere, which prevents the contamination of the atmosphere. So it has a long life. Disadvantages of natural draft. Even though having several advantages, there are some disadvantages in this natural draft. The maximum pressure available for producing natural draft by the chimney is hardly 10 to 20 mm of water under the normal atmospheric and flue gas temperatures. Okay, only if they attain this pressure and certain temperature only, this natural gas will be effectively utilized. The available draft reduces with increase in outside air temperature, and for generating enough draft, the exhaust gases has to be discharged at relatively high temperatures, resulting in the loss of overall plant efficiency. Thus, maximum utilization of heat is not possible. Now let's see about the artificial or mechanical draft. It has been seen that the draft produced by the chimney is affected by the atmospheric conditions. Yes. So it has no flexibility, poor efficiency, and tall chimney are required. So in most of the modern power plants, the draft applied must be freedom of atmospheric condition, and it should have more flexibility or control to bear the fluctuation loads on the plant. So in order to bear the more flexibility and free from so many atmospheric conditions, these modern power plants go for the artificial or mechanical draft instead of going for the natural draft. So what are the advantages of artificial or mechanical draft? It is more economical and its control is easy. The desired value of draft can be produced by mechanical means, which cannot produced by means of natural draft. It increases the rate of combustion by which low-grade fuel can also be used. It reduces the smoke level and increases the heat transfer coefficient, so no flue gases side, thus increases the thermal efficiency of the boiler. In mechanical draft, it saves the energy and the heat of the flue gases can be best utilized by it. So in this way, it reduces fuel consumption and makes boiler operation cheaper. It reduces the height of chimney, which now is only controlled by the requirement of pollution norms. And some of the disadvantages of artificial or mechanical draft. So the initial cost of mechanical draft system is high. The running cost is also high due to the requirement of electricity, but that is easily compensated by the savings in fuel consumption. So the maintenance cost is also at a higher rate. Noise level of boiler is also high due to noisy fan or blower, etc. So the types of artificial or mechanical draft. The following are the two types of artificial or mechanical draft. First is the steam jet draft. Second is the mechanical or fan draft. And following are the main two types of steam jet draft: induced steam jet draft and forced steam jet draft. In this session, we are not going to study about these two types. And the following are the three types of mechanical or fan draft: forced draft, induced draft, and balanced draft. In this session, we are going to study about these three topics. Let's see forced draft. In a forced draft system, a blower is installed near the base of the boiler. This draft system is known as positive draft system or forced draft system because the pressure of air throughout the system is above atmospheric pressure and air is forced to flow through the system. The arrangement of the system is shown in the figure. In the next slide we can see a stack or chimney is also used in this system as shown in figure, but it is not much significant for producing draft. So this is the layout of the forced draft system. So this blower is connected before the boiler. So this is the great furnace. Using this blower, the air is forced into the boiler system, so that this forced air can goes to the economizer and the air preheat then goes to the stack or chimney to exhaust. Let's see how this forced draft system is working. When the blower runs, air from the blower it goes to the furnace to the grate from its burning the fuel, so that the exhaust gas goes through the economizer and to the air preheater, and then through the chimney or stack it goes to the exhaust. So this is the forced draft system. During this forced draft system, the inside pressure in the boiler and the system is maintaining higher than the atmospheric pressure. Then comes the induced draft system. So in this system, the blower is located near the base of the chimney instead of near the grate. The air is sucked in the system by reducing the pressure through the system below atmosphere. The action of the induced draft is similar to the action of the chimney. The draft produced is independent of the temperature of the hot gases. Therefore, the gases may be discharged as cold as possible after recovering as much heat as possible in air preheater and economizer. So this is the layout of the induced draft system. In forced draft system, the blower we kept the blower here in before boiler, but in induced draft system, the blower is kept next to the air preheater before the chimney, so that when the blower runs, air from the atmosphere is sucked and goes to the furnace, and the fuel burn, and it goes to the economizer air preheater, then goes to the exhaust. So in this system, inside the total system, which is the pressure of the total system is maintaining lower than the atmospheric pressure. And one more thing, when the air hot fluid air, it comes to the economizer air preheater, and we can use any other applications, even though the exhaust air, the temperature is reduced, no problem, it can easily go to the exhaust. Okay, but in natural draft system, only if it reaches the higher temperature and higher pressure, then only it will goes through the chimney. But in induced draft system, we are using this blower in before the chimney. So this is the induced draft system. How this induced draft system works, let's see. So when the blower starts, air from the atmosphere, it goes to the furnace, it burn the fuel, oxidize the fuel, and the exhaust gas, it goes to the economizer and the air preheater, and then goes to the exhaust through chimney or stack. This draft is used generally when economizer and air preheater are incorporated in the system. The fan should be located at such a place that the temperature of the gas handled by the fan is lowest. Okay, the chimney is also used in the system, and its function is similar as mentioned in forced draft, but total draft produced in induced draft system is the sum of the draft produced by the fan and the chimney. Now let's come to the balanced draft system. The balanced draft is a combination of forced and induced draft. If the forced draft is used alone, then the furnace cannot be opened either for firing or inspection, because the high pressure air inside the furnace will try to blow out suddenly, and there is every chance of blowing out the fire completely and furnace stops. Yes, in forced draft system, the pressure inside the system, the boiler system, is maintaining higher than the atmospheric pressure. So in any case, for inspection or any reason, if you open the boiler, suddenly the fire comes, the high pressure fire blow out from the boiler. So this forced draft is alone cannot be used. Next, if the induced draft is used alone, then also furnace cannot be opened either for firing or inspection, because the cold air will try to rush into the furnace as the pressure inside the furnace is below atmospheric pressure. Yes, in induced draft system, the boiler pressure inside the boiler system, the pressure inside is maintained lower than the atmospheric pressure, so that for any case for firing or any inspection, if you open the boiler system, the outside high pressure atmospheric cold air, it rushes to enter into the furnace, so that it will destroy the pressure maintenance, pressure balance. Okay, so that this induced draft alone cannot be used. So to overcome both the difficulties mentioned above, either using forced draft or induced draft alone, a balanced draft is always preferred. So this is how the balanced draft layout is look. So the same time we are combining both the forced draft and the induced draft, which is called the balanced draft. In this balanced draft, The blower is kept in front of the boiler and the blower is kept in front of the chimney. Okay, so that it will maintain the balance in the system. Let's see how this balance draft is working. So when the two boilers working, so that air from the blower, it's used to burn the coal inside the furnace, and the exhaust gas from the furnace, it moves through the economizer and air preheater and then goes to the exhaust through chimney or stack. Now let's see the comparison between forced draft and induced draft system. In forced draft system, fan or blower is placed before the grate, and in induced draft system, fan or blower is placed after the grate. In forced draft system, the pressure inside the flue gases is slightly more than the atmospheric pressure, and in induced draft system, the pressure inside the flue gas is slightly less than the atmospheric pressure. In forced draft system, fan requires less power, but in induced draft system, fan requires more power. In forced draft system, the flow of the flue gases through the boiler is more uniform. In induced draft system, the flow of the flue gases through the boiler is less uniform. In forced draft system, the danger of fire in case of leakage of flue gases. There is a danger of fire in case of leakage of flue gases. It means the pressure inside the system is maintaining at higher pressure than the atmospheric pressure, so that any cause the fire inside the boiler or system will come rush out to the atmospheric outside. So no danger of fire in case of leakage of flue gases. So here the total overall pressure maintaining inside the induced draft system is less than the atmospheric pressure, so that the outside air can go inside instead of the inside a fire or inside flue gases, it rushes outside. So there is a no danger of fire in case of leakage of flue gases. So thank you students. In this topic, let's give a glance from this topic. We are seeing about the draft system. There are two types of draft system. One is the natural draft system and the other one is the forced draft, artificial draft system. Under this artificial draft system only, mechanical draft system, and this mechanical draft system, three types are there: forced draft, induced draft system and balanced draft system. Thank you students. We'll see in the next class.